Hi, this is Mel. Today we're gonna go through chapter 13, exponential functions and logarithm. This is VCE Math Method, Unit 1 and 2. Chapter summary. Okay, so for exponential and log functions, which we might directly look at the graph over here. So these two are the exponential functions. It can be whether increasing or decreasing, depends on the base a. And about the log functions, it look something like this, with always the intercept 1, 0. This is the x-axis and y-axis. So let's go through bit by bit. First, the index law. To multiply two powers with the same base, add the indices. So if we have, for example, base a with the power m times base a, also base a with the power n, the only condition here is the same base. Also for the dividing, if we have the same base, we can actually add the power m plus n. If we're dividing, also with condition same base, we're actually having the power m minus n. So to raise the power to another power, multiply the indices. If we already have a power, a to the power of m, we want to take another power, n. Then we can actually multiply them together, give us m times n. It's important to note that this is very different to this one. So we have a to the power m, and then for the m, we have another power n. So this n is on the power of m. This does not equal to a to the power m times n. Okay, let's move on to rational indices. So for rational indices, just like m on n, which is the power, something like this, this can actually give us a to the power m 1 on n. And a to the power of 1 on n is, so this line over here, the m divided by n, this line over here actually can correspond to the root. So if you have the denominator n, then it becomes root n with the same base a. So this gives us a to the power m with root n, equivalent to this one. Let's talk about the graphs. So graph of exponential functions. If we have the same base, a, if a is greater than 1, then the function will be increasing. Let's take an example. For example, if we have a is equal to 2. If x is equal to 1, then to the power of 1 is 2. If x is equal to 2, to the power of 2 equals 4. So it's increasing, which corresponds to the graph. If x is increasing, then y must be increasing. What about if we have a rational positive base a? So a is greater than 0 and less than 1. So for example, if we have half, a is equal to half. If x is equal to 1, then we have half to the power of 1, which is just half. X is equal to 2, we have quarter. So obviously it's decreasing. If x is decreasing, then y is decreasing. And to note that for any a, we have, if x is equal to 0, we observe that y is also always equal to 1. That's because a to the power of 0 always equal to 1. This do not change. Let's move on. If we have a is positive real number without 1, what if a is equal to 1? Let's think. If a is equal to 1, then we have 1 to the power x, which equal to 1, no matter what value x can take. So if a to the power of x is equal to the a to the power of y, if we have the same base a, then the power must be the same. X is equal to y. With the same condition, if we have a to the power of x is equal to y, this relates us with the log function. So let's see. So for this one, we're actually calculating what's the result of the a to the power of x. It gives us y. But for log, instead of calculating the answer y, we're finding the power x. Which power x give us with the base of a and the answer of y. So we're finding the x. With base a and the answer y, what's the power? And it turns out it's x. So this is very important. You should know how the exponential and log are equivalent by changing the position of x and y. Let's then talk about laws of logarithms. So if we know this part, if we know the index law very well, then it's very easy for you to understand laws of algorithm. Let's go through bit by bit and try to find the corresponding index law. So if we have log a mn, it's actually equal to the sum of log a m plus log a n. This corresponds with our rule am times an equal to am plus n. So let's highlight this bit by bit. We have log am corresponds to this part. Log an corresponds to a to the power of n, and log am times n equal to corresponds with a to the power of m plus n. Let's also do the division one. So log a base a with m divided by n is equal to the subtraction of log am and log an. This corresponds with am divided by an equal to am minus n. Let's also highlight this one. Log an corresponds with log a, and log am divided by n corresponds to a to the power m minus n. So point 3, this is pretty special. We can take, if we have log a and inside its power, m to the power of p, we can actually take the p out, p down to the in front, which becomes p times log am. And similarly for point 4 is a special case for point 3. If we have p equal to -1, then we can take the -1 down. It becomes negative log am. So point 5 is very interesting. Also corresponds with our exponential is equal to 1, which we talked about earlier over here. So any base a with a power of 0, we must have the answer of 1. And for base a power 1, Let's say power 1 is equal to itself a. Okay, that's it for today. Thanks for listening. Hope I help you with exponential and log functions. Thank you.